With problem number 20, we're looking for the derivative of this function x cubed plus x squared using the limit definition. This one is a little bit more complicated because we have a cubic function in it. But we'll go ahead and get started. We're looking for f prime of x, the derivative of f of x, which is x cubed plus x squared. And that is the limit as delta x approaches 0 of f of x plus delta x minus f of x and all over delta x. So when we go to plug in now, we have the limit as delta x approaches 0 of x plus delta x quantity cubed plus x plus delta x quantity squared. And of course that's minus the quantity x cubed plus x squared, which is f of x all over delta x. Now we've already seen how to do the x plus delta x quantity squared. X plus delta x quantity cubed is going to use the binomial theorem. And so this expression is going to have 4 terms, and the coefficients of those terms are going to be derived from the third row starting at 0, 0, 1, 2, 3, third row of Pascal's triangle. So we'll have coefficients of 1, 3, 3, and 1. Now you could just multiply out. You could make this x plus delta x squared and times x plus delta x and then multiply it out. But this way is just as easy once you get used to it. Then each of these will have an x times delta x, and they'll all be added together. Then the x terms will start with exponent 3 and work themselves down to 0. The delta x's will start at 0 and work themselves up to 3. And so if we simplify there, we simply get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. By the way, x plus delta x squared also can be found using the same principle, only it will use the 0, 1, 2 second row. And there will be 3 terms whose coefficients are 1, 2, and 1. And each term will have an x and a delta x factor. And the x's will start at 2 and work themselves down to 0. Delta x's will start at 0 and work themselves up to 2. Simplifying, we get x squared plus 2x delta x plus delta x squared. And so now we can put all of that together. We have the limit as delta x approaches 0 of x plus delta x cubed, which was x cubed, plus 3x squared delta x, plus 3x delta x squared, plus delta x cubed. Then we're going to add to that x plus delta x squared, which is x squared, plus 2x delta x, plus delta x squared, and then minus x cubed and minus x squared. And that's all over delta x. Okay, so not too bad. A lot of terms, but not too bad. Now we need to combine like terms here. And first of all, anything without a delta x should disappear. Let's see. We have x cubed and negative x cubed, x squared and negative x squared, and it appears that everything else has a delta x in it. So we have x squared delta x delta x squared, delta x cubed, x delta x, and a delta x squared. So it doesn't look like any of those are going to be able to be combined together. What we can do though is factor out the delta x in the numerator, leaving 3x squared plus 3x delta x plus delta x squared plus 2x plus delta x all over delta x, and the delta x factors will cancel. And at that point I can go ahead and set any remaining delta x's to 0, and that's going to wipe out everything except for the 3x squared and plus the 2x. And that is the derivative of x cubed plus x squared, using the limit definition of the derivative. We'll continue in the next video.